Hello all, here is a very important question from electrostatics of conductors. What happens when two conductors are touched with each other? What we have here is one conductor is having charge Q and another conductor has no charge, it is uncharged. First of all, we see that on the first conductor whatever charge is given, it is present only on the outer surface. Why does the charge stay only on the outer surface? Due to mutual repulsion from each other. Suppose we put all these charges at the center of this sphere here, then what will happen that due to repulsion from each other they will all move outwards and they will reach the outer surface. That is why the charges always remain on the outer surface. Now when we connect these two conductors with a wire, or if you just touch them, what is going to happen to the charges? So here we have touched them. The charged conductor is now touched or made in contact with the uncharged conductor. What will happen now? Now you know that the charges which are present on the first sphere, they are already under mutual repulsion with each other. Due to the mutual repulsion from each other, these charges want to travel as far as away distance from each other. So when you touch the second conductor, these charges get an opportunity to travel some more distance onto the other sphere. So due to this repulsion, they would like to go away from each other, and so they travel onto the next sphere. So some charges from the first sphere would travel into the second uncharged sphere or uncharged conductor. Finally, we will have this situation where the charge Q from the first sphere will get equally divided among both the spheres. Why equally divided? Because they have same shape and same size. If they are identical in shape and size, then the charge on the first conductor would be equally divided among both of these. Okay. What will happen if these spheres are not of the same size? Suppose the first sphere was having radius r1 and the second uncharged conductor was having radius r2. These are metallic spheres and the first one contains charge q. Once again, due to the mutual repulsion, charges from the first sphere will begin to travel into the second sphere after they are made in contact. In the second figure we see that they are in contact with each other. As soon as they are made to touch with each other, due to repulsion, charges will begin to flow from the first sphere to the second sphere. But because the radius of the sphere is not same, the amount of charge that will go onto the second sphere will not be the half of the first charge. So, due to the repulsion, now the second sphere is also charged. Let us now separate them from each other. After they are fully charged, we separate them from each other, and the final charge that will be present on both of these are not equal. You see, these charges are given by Q1 is equal to R1 divided by R1 plus R2 into the Q initial charge, and Q2 charge on the second sphere is R2 by R1 plus R2 into the charge Q initial charge. We notice here that the charge Q1 is directly proportional to its radius R1 and the charge Q2 is directly proportional to the radius R2. That means smaller radius will contain less charge and the larger radius will contain more amount of charge. And we see that if the radius are not equal, then the charges are also not equal. They are in the proportion of their radii. What if both are charged and both have same size? Let us consider the situation where we have two metallic spheres, both of them having the same radius, they are having same shape and same size, and both are conductors, but the charge on them are different. If you touch both of them, what will happen to the charges? Will they flow? If we assume that Q1 is greater than Q2, that means the charge on the first sphere is more than the charge on the second sphere. So we can say the repulsion on the first sphere is more than the repulsion on the second sphere. Okay, therefore the charge will flow from the first sphere to the second sphere. This arrow represents the direction of the charge flow. Now charges will flow until the charge on both of them becomes equal. That means the charge will become arithmetic mean q1 plus q2 divided by 2 on both of them. So the first sphere had charge q1, second sphere had charge q2. After we made in contact with each other, finally the charges on both the spheres would be equal, and that would be the arithmetic mean of both the charges given to them. Also, please note down, sometimes the charge q2 or q1 may be negative, so we must put the proper minus sign also for each of these. For example, let us say the charge q1 is positive value. Let us say the charge q1 is 5 coulomb plus sign, and suppose the charge q2 is minus 7 coulombs. So what will be the final charge on both the spheres? So 5, we have to add q1 plus q2. 5 minus 7 will be minus 2, and minus 2 divided by 2 will be minus 1. So therefore we can say final answer would be minus 1 coulomb and minus 1 coulomb on both of them. So we have to calculate the arithmetic mean of the charges with their proper positive and negative sign if the radius of both the spheres are equal. So this is important formula. q1 plus q2 by 2 arithmetic mean will be the total amount of charge on each of the sphere if they are having same radius. I hope you like this. Thank you, and please like the video.